So hey guys, how are you all? I hope you all are fine and safe. And now you cannot see me, but now you can see. Okay, so first of all, let me just tell you, I am Aman Gupta from India, a class 12th grader student. Today what we are going to discuss is, um, I'm not sure, but I got something like I got a closed form of this function. It's zeta of 3, like the Riemann zeta function of 3, and this is the series from n equals 1 to infinity of 1 over n cubed. Well, look guys, I hope you are familiar with Riemann zeta function, and if you are not, then it's the, let me just tell you what's Riemann zeta function firstly. Well, look, so yeah, Riemann zeta function is just, well, it's not just a series, but it's a great series, represented like that, where n is, you can say, the real part of a complex number. Yeah, it's like that. Well, so I hope you are familiar with this. It's not a big deal, and if you are a Calc 1 or Calc 2 student, it's basically it's in Calc 2 and Calc 3. I think it's not in Calc 1. Although we are going to discuss this, I'm just going to explain you with the easier way. Like, I'm just going to evaluate this using this Fourier series, just for that sake. Okay, well, look, if I'm going to tell you something about Riemann zeta function, then look, for some constants like 1, 2, 3, we are going to discuss about it. Well, the zeta of 1 is divergent. Its divergence to infinity, you can check it out. Just put 1 on the place of s, so you would have the summation from the series from n equals 1 to infinity of 1 over n. So it's divergent. It's not easy to, like, it's not evaluable, like, right? Okay, but what's zeta of 2? It's known as the Basel problem, and well, the value of zeta of 2 is pi squared over 6. Well, I've proved this using Fourier series, and if you want a video to prove this with Fourier series, I would just make a video on. Well, it was easy. It's just nothing, I think. Zeta of 3. Well, it's known as Apery's constant, but I'm just going to evaluate this in today's video. Well, look, maybe I'm wrong, but according to my solution, like I have written, like this is my handwritten solution of zeta function. I have zeta 3. So, like, according to me, I didn't do any mistake in this. Let's see. Well, I will try to just solve something. Like, look, I'm not going to copy all this thing. I would solve some steps. Like, I'm not just copying it, but I would be solving some steps for you, like, for your comfortableness, right? Okay, anyways, let's move on to the zeta of 4. We have zeta of 4. Well, I don't know what it's called as, but whatever it is, the value of zeta of 4 is, I think, pi to the 4th over 90. And I think, as much as I can remember, zeta of 6 is pi to the 6th over 1576, I think. Let me just check it out, right? Actually, I have evaluated the zeta of 6 also. Yeah, here it is. So it's 9:45. Yeah, sorry guys, actually, well, it's 5 to the 6 over 9:45. Yeah, well, 5 to the 6th, I have evaluated it, but you know what? I don't think that there is anyone in this world that have evaluated zeta of 3 like I did. And if there is anyone, yeah, that's good thing. Well, I think that I'm just getting wrong answer just because there is no one. But well, I do believe on my steps. I do believe on my result. So let's begin the proof, right? Well, I'm not gonna just publish it on YouTube to make it private. Okay. Anyways, guys, whoever you are watching this video, I think you are going to be a lucky person after me. So, yeah. Before everything, let me just let me just make you familiar. Let me just make you familiar with Fourier series, right? Well, look, Fourier series is a representation of a function in terms of a series, like infinite series. Look, so we have f of x as, like, it's a Fourier series. Fourier series representation. So we have f of x. F of x can be anything, x squared, and anything. F of x has a naught over 2 plus the series from n equals 1 to infinity of a n cosine nx plus the sum from n equals 1 to infinity of b n sine of nx. You need to keep remember this. This is the, I think, best thing. Like, this is the most fundamental thing I'm going to use to evaluate zeta 3, right? Okay, so you might think that what is a naught or a n or b n? So all these three are integrals. Well, let me just tell you what's a naught is the integral of, like, a naught equals 1 over pi times the integral of f of x dx. Well, the bounds would be given, I think. Like, I'm just going to evaluate zeta of 3 in bounds like negative pi to pi. But I would just, like, look, if I'm just having a function, like, look, I'm just having a function, let g of x, and I'm just saying that this function belongs to negative pi to pi. So you are going to evaluate this integral from negative pi to pi, right? This the bounds is depending on the function and from where it is going, and from where it is coming, and where it will go, right? So we have a naught as this, and for a n is the integral, like 1 over pi is the integral of f of x times cos nx dx, and similarly for bn, 1 over pi f of x times sine of nx dx. So just keep remember these things, and this is what Fourier series is. It is. Well, let me just check whether you can see everything or not. Well, I would explain you again. Yeah. So here's my paper. Fourier series. Yeah. Fourier series representation has done. Well, look. And now what I'm going to have is, like, for this thing, the Fourier series, right? So for f of x cubed, well, and again the bounds x belongs to negative pi to pi. So we have to just find the Fourier series of x cubed, and the bounds are here, right? It's not a big deal. Just put f of x as x cube over here and just equate it, and just evaluate a naught an well an with this integrals and bn, and then we are good to go. Yeah. So yeah, let's do this. So we have the Fourier representation, the Fourier series for f of x as x cubed, where x belonging to negative pi to pi. Well, this is going to help us in evaluation of a naught, a n, and bn. So we have x cubed as a naught over 2 plus the series from n equals 1 to infinity of a n cosine of nx plus the series from n equals 1 to infinity bn sine of nx, right? So this is the Fourier representation of x cube. And now what we are going to simply evaluate, what we are going to do is to simply evaluate a naught, a n, and bn, and then only we can proceed. So for that sake, just getting evaluated like now let me just put it in a bracket. I hope you can see that. Let me just check it, right? Oh yeah, it's good. Well, my phone is not that much good in camera quality, I think, and this is quite big. This is quite weird, so that's why you need to compromise, guys. But wherever you are just finding any difficulties, I would just provide you solution for that. I would just clear your doubts. So now, and I'm just trying to write as much as bigger I can, evaluating a naught, a n, and b n, and then just put the values of a naught, a n, and b n. So this is represented in terms of a series, and now I think, well, let's do this. So for a naught, I told you that a naught is the integral. Well, look at it. A naught is 1 over pi times the integral. With limits, we have negative pi to pi. F of x, which is x cubed. Well, look, if you are good at calculus, then you can see that x cube is an odd function, and the integral, let me just tell you, right? I'm just going to explain each and every step as much as I can. Just have a look at this board. So the integral from negative a to a of f of x dx, where f of x is an odd function. Well, what is odd function? So odd function is just f of negative x, look, f of negative x equals negative of f of x. So this is an odd function, and if this integral looks like, then its value is 0. So look, we have a as pi from negative pi to pi, and f of x as x cube, so it's just gonna be collapses to 0. So finally we have easily calculated that a naught. Should I just write it? I think I should just a naught to 0. Just keep remember that a naught is 0, right? And for my preference, I'm just gonna write it a naught is 0, right? Well, it was easy, huh? It was easy, but look, guys, mathematics is like, if you are just feeling it, you got everything. You don't need to just be worried that I cannot understand maths. It's very difficult. It's like a love, man. And don't get a girlfriend, just get maths. Well, it's my personal thing, and if you're finding it somewhere offensive, then just please sorry. Just forgive me, right? Well, okay, now we have to evaluate a naught, right? So what we are going to do is just evaluate a naught right over here. So what a naught is, the integ 1 over pi, just keep remember, from negative pi to pi, bounds, and we have f of x, which is x cubed times the cosine of an x. Right, look. Just look at this carefully, guys. Just look at this carefully. Okay, we have an odd function, right? And cosine of nx is every time it's just n is anything, it's positive. So what, let me just tell you again this thing. Look, I have f of x as x cubed times cosine of nx. F of minus x cubed. Cosine of minus nx is just nx. So f of x, f of negative x is just negative of f of x. Hence this function is odd, and then it's going to be 0 again. So we have successfully evaluated that this is not a naught, my bad, an. So an is also 0. Oh man, like it's going easy, huh? Well, just wait for bn. It's just coming and just having a lot of surprises for you guys. Just wait for the moment. And now that moment comes and we are going to evaluate bn. Well, look, x cubed is an odd function, sine of nx is an odd function, so they both are going to be just make an even function, and then we have to evaluate this integral. It's going to be fun. Okay. Well, an is 0. Well, look guys, from here till here I am just ignoring this paper just because I want you to explain. I would just publish this paper and you can see that, but I have tablet or I have pen tab and laptop. I would just highlight everything and just explain you, but I want you to explain everything what I did, right? So, well, if somewhere I got stuck, I would just come back to paper and look at it, like how I'm getting stuck. But till now, I am smooth. Now it's time to evaluate bn. Bn is 1 over pi, and the integral from negative pi to pi x cubed times, well, not cosine, sine of. Okay, this is quite good. Okay, so, well, you can see that it's an even function, so we can just double the result and evaluate the integral from 0 to pi. So we have bn as 2 over pi, 0 to pi. Okay, so now what I'm going to use to evaluate this integral is DI method. Well, DI method is a new way, a best way, I think, for biparts, and it's introduced by BPRP, Black Pen Red Pen. He's great. He's great teacher or professor, whatever it is, but he is great. I love him. So if you want to just get deeper into this method, just you have to, or you can evaluate it by our basic biparts. Like, I'm not going to explain you, like it's going to take time. So we have the derivative of x cube and the integral of sine of nx. So the derivative of x cube is 3x squared, and then it's just 6x, and then it's just 6, right? And the integral of sine, it's negative 1 over cosine of nx. You can just take that, you can just integrate it and you would have this result. And when you integrate this thing, cosine of nx, we have negative 1 over n squared sine of nx, and again we have 1 over n cubed cos of, like the integral of sine of x is just negative cosine. So negative and negative would just cancel out each other, and 1 over n would be multiplied with n, 1 over n squared, and it would be 1 cube, 1 over n cube, and times cosine of nx, right? Okay, let me again check that everything you can see, right? Oh well, guys, how can you not see? Okay, so and it's oh. Well, guys, I know that if you are not familiar with this method, you are finding it difficult to understand. But I just want you to, like, I would recommend you to just watch the DI method on the channel of BPRP, that is black pen, red pen, and then come to this video at this point, and then continue the video. And yeah, like once you understand, na, you would forget every by parts method instead of this, because this is easiest, I think. So we have our Bn as 2 over pi negative 1 over negative x cubed and plus 3x squared sine of nx over n squared and plus 6 cos n over n cubed from 0 to pi, and a negative 6 over n cubed integral from 0 to pi of cosine of, well, so let me just have a look that I'm just getting all everything wrong, right. 6, oh, I just forgot x. Yeah, that's why I'm just having a paper in which I did everything right. We have 6x cos 6x cos nx, right? So we have 6x cos nx over n cubed, and this is going to be 0, and negative x cubed cos nx over n, evaluating from 0 to pi. Look, guys, if you don't know, I think I should erase this. But before that, let me just tell you over here. If you know that sine of 0 is 0 and this is equal to sine of pi, right? So, well, as we can see, our n is just a natural number. So, for every natural number, sine n pi, so look, I think I should just explain you in deep. Okay, so till here I hope you can understand that, and this Fourier series you need to just explain, you need to just understand, right? I think I should just represent that. Okay, anyways, I have paper and you have video. You can just move back and forth as you want for your preference. Well, look, I'm just going to have Bn as 2 over pi, and we have negative x cubed cos nx over n plus 3x squared and plus 6x cos nx over n cubed, evaluating from 0 to pi, and we have this negative integral, right? So we have negative 6 over n cube, the integral from 0 to pi of cosine of nx. Well guys, okay, when you plug pi in this bracket, so we have bn, like this 2 over pi is just getting multiplied with this integral also, just keep remember that. And so we have this plugging pi on the place of x in this bracket. We have negative pi cube cos n pi over n plus 3 pi squared sine n pi over n squared plus 6 pi cos n pi over n cubed, right? And then just putting 0, so look, like on the place of x, 0 times anything 0, 0 times anything 0, 0, so this is going to be 0, right? And then we have this integral, we have negative 6 over n to the 4th sine of nx, I think, yeah, evaluating from 0 to pi. Look, sine of n pi is always 0. So this thing is 0, so this thing is going to be 0. And if this thing is 0, then like sine n pi and sine 0 is all 0, so this is going to be 0. So what we are going to left with is just bn as this thing. We have, I'm just writing this term first so that this negative is just messing up for me. 6x cos nx n cubed negative pi cubed cos, oh well, it's not x, it's pi, 6 pi, my bad guys, cos n pi, well, I'm just having some mistake, but I would correct it. So yeah, we have 2 over pi times 6 pi cos n pi over n cubed, cos pi, 6 pi cos n pi over n cubed, and minus this thing, right? Okay, so just let's just get rid of everything, and let me just check I'm just having everything right. Yeah, so just erasing all these stuffs. So what we have is bn as 2 over pi 6 pi cos n pi over n cubed minus x cubed cos n pi, well, it's not x, pi cubed over n, and just multiplying this 2 over pi into this thing, we would have bn as 12 cos n pi over n cubed. Yeah. Okay. 12 cos n pi over n cubed, and we have negative 2 pi squared cos n pi over n. Well, this pi would be cancelled this pi, and pi squared we would have left with it. So we have bn as that thing. Well, more precisely, as you know that cos n pi is just negative 1 to the n, where n is natural number. So I'm just replacing cos n pi with this thing. So we would have bn as 12, well, it's just negative 1 to the n cubed negative 2 pi squared negative 1 to the n over n. Just close it in a bracket. Fine guys. Oh yeah. Well, yeah, it's good. Okay, and now just putting bn here and this, but let me just erase all these stuffs. And before that, let me just check everything is going right? Oh yeah. So actually, guys, uh, I'm just having a little cough with me. That's why it's difficult for me to speak, but I will speak. Okay, so we have bn as that thing, right? And we had, like, remember, we had x cubed as a naught over 2 plus this series from n equals 1 to infinity of a n cos n x plus the again series of bn sine of nx from n equals 1 to infinity. Well, we had a naught and a n calculated as 0. So, well, 0 times anything is just 0, so this is going to be 0, and 0 over 2 is just 0. So we are just left with that series x cubed as this thing. Well, we have bn. Just plugging out that bn over here, so we would have x cubed as 12 times negative 1 to the n over n cube and minus 2 pi squared negative 1 to the n over n, and we have sine of nx. Okay guys, so and what I did is when I'm having x equals pi over 2, you know what guys, like, I'm just having trouble with this thing, and that's why we cannot evaluate the zeta of odd numbers like zeta of 1, zeta of 3, zeta of 5, zeta of 7, and so on, just because this disturbs us. And we cannot, like we had, look, remember, we had cos of n pi as negative 1 to the n, a general form of representation when x is pi. But for this thing, we have nothing. And what I did, I think I did mistake. And look, I think you can see that I just I just put x equals pi over 2, and sine of n times pi over 2 is 1. I just did a mistake. Well, when n is 1, it's 1, but when n is 2, sine of pi is 0, and when n is 3, it's just negative 1. So it's just moving around 1, 0, and negative 1, and there is no general form of it to represent. And that's why just getting stuck over here. Okay guys, I think, look, I have to just work upon it. I think it's not what I thought. Guys, just let me have some time to just think about the sign of nx, on which value of x I would, like, look guys, this thing, this negative 1 to the n over n cube, but is a constant, so it would be outside the summation. So negative 1 to the n over n cube is negative 3 over pi zeta of 3. So if I got rid of this thing, I would have zeta of 3 in this equation, and then I would be able to calculate it. And this thing, like 2 pi squared is just constant, so it would be outside the summation. And we would have the negative 1 to the n over n. It's just negative ln 2. So I got sorted out everything, but instead of this thing. And for that I need time. I'm just thinking about if x equals pi over 4, then it be generalized like cos n pi. Well, I'm just gonna pause the video and I'm just gonna have my time, but it's just a second for you guys, so just wait for that second. So yeah guys, back. For me it was 10 minutes, and for you guys it's a second later. So, well, unfortunately I would say that I am failed, and I cannot just evaluate zeta of 3. You know what I did mistake in this paper? I'm going to explain you that. And yeah, that's a stupidity. That's a stupidity, I think. Well, what I did is just replace x with pi over 2. So pi over 2 whole cubed, and we have this series. This was my stupidity, I think. And I did this to get rid of sine of this and pi by 2. And what I did that just made me a stupid or an idiot is I just put this thing as 1. But I didn't thought that when n is 1 it's good, but when n is 2 it's 0, and when n is 3 it's just negative 1. So this is wrong, and that's why further from here I cannot go further, and that's why I cannot evaluate zeta of 3. I am too close to it, but for me to evaluate zeta of 3, I have to just get rid of this thing, and I cannot, because sine is a wavy function. I think sine is a wavy function, so its values are changing when n is just getting odd, even, or uh, I'm so sorry guys, you are watching this video and you got nothing. I'm so sorry, but I really apologize. I'm really apologizing for this, but maybe you got something to learn. Maybe you got to learn about the Fourier series. That's gonna help you, but I'm just gonna tear that paper, and that's ridiculously wrong. Here I just write wrong step over there. I just cut it down. This is wrong. I evaluated zeta of 3 like this, and this is wrong. This is the biggest mistake. Okay, so hope you guys enjoyed. I hope you guys enjoyed this video, and I hope you got to know something from this video. Well, what I wanted to just show you, you got nothing like that. But well, when you just put x equals pi over 2, so, and when you just divide this sum into even numbers and the odd numbers, then the even would be just going to 0, right? But the odd, for odd sine n pi, when n is odd, it's just negative 1 to the n minus 1 over 2. And then what you just multiply this thing into this, and you would have something better results, like a you can just have any good result for this solution. Well, I'm slightly disappointed and I'm not going to explain you that. Well, I hope that I did I did something great. I did evaluate the zeta of 3, but I cannot, and that is why it is $1 million question. It is $1 million problem. Anyways, guys, thank you so much for watching this video, and well, thank you so much. Just meet you in the next video.